Hello students, now we are discussing our chapter General Organic Chemistry. In last lecture, we are discussing IUPAC nomenclature for organic compounds. In that lecture, we discussed that organic compound, when we consider a nomenclature of organic compounds, in nomenclature of organic compounds, the three important parts are there. One is the root word, second is the suffix, and third is the prefix. So by considering these three togetherly, we are able to write the IUPAC name of the organic compound. We also know that the root word will be used and ideas about the length of the carbon chain. Length of carbon chain. How much long is the carbon chain, that will be understand from the root word. Suppose the carbon chain of the 5 carbon, its name is the pentane. Suffix. Suffix is again the two type, primary suffix and secondary suffix. Primary suffix will be used and ideas that it has a carbon-carbon single bond or carbon-carbon double bond or carbon-carbon triple bond. If the given organic compound contains carbon-carbon single bond, we use a suffix as ANE. For double bond, we use ENE. For the triple bond, we use YNE. Okay. In the case of the secondary suffix gives an idea about the functional group, which functional group the given organic compound can possess. And the prefix, these prefix are used in the case of those organic compound, particularly the halogens, chlorine, bromine, iodine, or the nitro compounds, or the alkyl groups which are present here. In that case, we can use a prefix. So this idea we know in the last we know about this in the last lecture. Now in today's session, we are discussing the two important points, that is the IUPAC nomenclature of organic compounds. So for deciding the IUPAC nomenclature of the organic compound, we require IUPAC rules of the organic compound. So before we are discussing the general common IUPAC rules of the organic compound, we come for the what are the straight chain hydrocarbon and branched chain hydrocarbon, where we discuss the IUPAC rules of nomenclature of branched chain hydrocarbons. Okay, so we know that we consider the straight chain hydrocarbon. In the straight chain hydrocarbon, we consider a carbon number. The carbon number, if you consider, then we consider the molecular formula. Then we consider its condensed formula, and then we consider its IUPAC name. Then we consider its IUPAC name. Now look at, we are discussing the straight chain hydrocarbon. What are all these things? We are considering about the straight chain hydrocarbon. In straight chain hydrocarbons, the carbon number is 1, its molecular formula is a CH4, its condensed formula is a CH4, it is given name as a methane. Then carbon number 2, C2H6, condensed formula CH3, its name is ethane. So all these things we actually already discussed in the first lecture. Carbon number 3, C3H8, condensed formula CH3, CH2, propane. Then carbon number 4, C4H10, CH3, CH2 twice, one CH2 group is increases, so it is the butane. Carbon number 5, C5H12, CH3, CH2 thrice, CH3, pentane. Carbon number 6, C6H14, CH3, CH24, CH3, then it has a hexane. Okay, so like this way, you can consider the IUPAC name of the alkanes by considering the carbon. CH3, CH2, 5, CH3, that is the heptane. Then 8 octane, this is the octane. Then 9 nonane, then 10 decane. Okay, so like this way you consider the nomenclature in the case of the this is nomenclature of the organic compound, where you consider the straight chain hydrocarbon. Okay, now go for the branched chain hydrocarbon. Okay, in the case of the branched chain hydrocarbon, now we consider what happened in the case of the branched chain hydrocarbon. So when you consider branched chain hydrocarbons, in branched chain hydrocarbons we consider its common name also and its IUPAC name also. So we know that when you consider alkane, alkane is formula CnH2n plus 2, from which you can write the alkyl CnH2n plus 1. That alkyl you can consider its common and IUPAC name. So you consider its common name and IUPAC name. Now we can write their common and IUPAC name. Let us consider the carbon number 1. Carbon number 1 is having alkane as a CH4. We called it as a methane. Its alkyl will obtained by removing the one hydrogen, that is the methyl. Okay, so therefore its common name is a methyl. Okay, and its IUPAC name is also methyl. Then next is the carbon number 2, C2H6. C2H6 having the alkyl C2H5. C2H5 we can also write as a CS3CH2 by the same way. Its common name is ethyl. It is also called as ethyl. So then up to the carbon number 1 and 2 you can consider straight chain. C3H8, that is the next is the propane. So this is ethane. Ethane gives ethyl. Then propane. If you consider propane, if you consider the straight chain alkyl like this way. You consider the straight chain alkyl. This straight chain alkyl is called as N-propyl because it is straight chain, 3 carbon, so it is N-propyl. Okay, so its IUPAC name is also N-propyl. But when you write this straight chain, we can have the one alkyl group also. That one alkyl group is obtained by replacing the primary hydrogen from the primary carbon, you get N-propyl. But if you replace the secondary carbon which is attached to 2. If you replace the hydrogen from the secondary carbon, you can get this type of the alkyl group, and that alkyl group is a carbon is attached with the 2-methyl. It is called as a isopropyl. Okay. So how you write the name of this isopropyl, IUPAC name? So in writing the IUPAC name of this N-propyl, we have to give the numbering from the carbon, which is where the branching is there. So branching is started from this. So I give the number, the carbon number 1 and carbon number 2. So when I write the carbon number 1 and 2, this group is remain as so this group is a methyl. So its name is a 1-methyl, and there are the 2 carbon, and the 2 carbon group is a CH3CH2, that is the ethyl. So its name is 1-methyl and ethyl. I again repeat, the branching is from here, give the numbering here 1 and 2. So it is a 2-member ethyl, and the 2-member ethyl at 1 carbon methyl group is there, so its name is a 1-methyl and ethyl, its IUPAC. Okay. Similarly, we consider the propane. Now go further. Next is the butane. So butane, C4H10. So this is a butane. In butane, we can write the straight chain butane, CH3, CH2, CH2, CH2. So as it is straight chain, it is called as a N-butyl. It is called as a N-butyl. Its IUPAC name is also N-butyl. Okay. But when I consider, so when I replace the again primary hydrogen from the butane. Okay. When I replace the secondary hydrogen, I get CH3, CH2, CH, CH3. So I get this is secondary. Look at these two are secondary. So you replace the hydrogen from this carbon or this carbon, both is the same. Now I replace the hydrogen from this secondary carbon. So what I get? I get this is the secondary butyl. It is not iso, it is a secondary butyl. Okay. So what is the IUPAC name of this secondary butyl? So where is the branching? The branching is from here. Now 1, 2 if you consider it has only 2 carbon, but if you go 1, 2 and 3, it has a maximum number of the carbon, there are 3. So you try to select the alkyl of the maximum number of the carbon. So maximum number of the carbon alkyl is a propyl. And at 1, there is one group is there, that is 1-methyl. Its name is a 1-methyl propyl. Its name is a 1-methyl propyl. So like this way, you can consider IUPAC name for straight chain and branched chain alkyl. Now go for the next, that is the butane. In butane, one more is there, and that is the isobutane. We also know that isobutane. In previous lecture, we already discussed all this thing. So if you consider isobutane, what happened in isobutane? So this is a isobutane. How we identify isobutane? There is a 1-methyl group on the second carbon. There are total 4 carbons, so it is isobutane. In isobutane, we consider a different type of the branching. So these carbons are the primary carbon. Okay. If I replace the hydrogen from this, I get one type of this branching. If I replace the hydrogen from this carbon, that is called as a tertiary carbon. Remember, 1, 2, 3 primary carbon. This is the tertiary carbon. If I replace the hydrogen from the tertiary carbon, I get this type of the branching. Okay. So isobutane has 3 primary carbon, which has the 9 hydrogen, and 1 is a tertiary carbon. Okay. So if I replace the hydrogen from the primary carbon, I get this group, and this group is called as there is a 1-methyl group on the second carbon, so it is a iso. So iso 1, 2, 3, 4. So it is isobutyl. And this is a carbon is attached with a 3-methyl group. It is called as a tertiary butyl. So tertiary butyl is common name. Okay. So how you write the IUPAC name? So again, in writing the IUPAC name, you can select the longest chain 1, 2, and 3. So this is longest chain is of the carbon 3. That is a N-propyl, on which there is a methyl group on the second carbon. So it is called as a 2-methyl propyl. It is called as a 2-methyl propyl. So in the tertiary, when you consider tertiary, what happened in the tertiary? I again try to write longest chain. The longest chain is a 1, 2 or 1, 2 or 1, 2. So it is a ethyl. Okay. So on ethyl, there are the 2 methyl group. This is 1 and this one. They are the same. So I write 1,1-dimethyl ethyl. So its name is 1,1-dimethyl ethyl. So like this way, in the case of the branched chain hydrocarbon, we can write the common and IUPAC name of the alkyl groups. Okay, and again repeat. Particularly, I repeat for the butane. I repeat for the propane. When I consider propane, N-propyl and isopropyl. When I consider butane, N-butyl and secondary butyl. When I consider isobutane, isobutyl and tertiary butyl. So while writing the name of all these branched groups, I can give the numbering at the branched alkyl group. I will try to select the longest alkyl group, and after selecting the longest alkyl group, whatever the alkyl group is remain, that I number. For example, in isopropyl, it is a 1-methyl ethyl. In the case of the secondary butyl, its name is a 1, 2, 3. So it is a propyl. So it is 1-methyl propyl. In the case of the isobutyl, the numbering is at 2. So 2-methyl propyl. The numbering is not given from here. The numbering is always from this branching. Here is 1,1-dimethyl ethyl. So like this way, you can consider the common and IUPAC name of the branched alkyl group that we require in the IUPAC nomenclature of the branched chain hydrocarbons. Okay. Now we discuss what are the basic rules of the nomenclature of the branched chain hydrocarbon. The rule number 1, rule 1 is the longest chain rule. So what is the longest chain rule? So according to this rule, we have to select longest continuous carbon chain. We have to select longest continuous carbon chain as a parent chain or parent hydrocarbon. Whatever the organic compound, that organic compound has a first, we have to select a longest continuous carbon chain, and that is your parent hydrocarbon. Suppose I have this compound. I have to write the name of this organic compound. So when I have to write the name of this organic compound, I have to select the longest continuous carbon chain. So I can select the longest continuous chain as this. How many carbon? 1, 2, 3, 4, 5 or 6. So it has a 6 carbon. So its parent hydrocarbon is a hexane. Okay. So this compound is a derivative of hexane. Or I may select this organic compound having the parent as this way, because it also has the 6 carbon. So this or this, both are the same. So one thing is clear, it has a parent hydrocarbon as a hexane. So when we have to do here, when I write select the longest continuous chain, so both are the same. So I go by this way or this way. So whatever the group is remain here, these groups are called as substituent or branched alkyl groups. They are called as substituent or branched alkyl groups. So in this compound, the parent chain is of the 6 carbon, so hexane, and one group is remain which is not a number in this, and that is called as a branched alkyl group. Okay, or these are also called as a substituent. Now the second rule. So when you consider, the first rule is the select the longest continuous carbon chain, and that is your parent chain. The second rule is the lowest numbering of carbon chain. Now we have to give the numbering to the parent chain so that it has a lowest number. Whatever the group which is attached, means alkyl group, has a lowest possible number. Suppose I consider the example. Suppose I have to consider the nomenclature of this compound. The first is the select the longest chain. So I can select the longest chain like this way. 1, 2, 3, 4, 5, 6. Again, hexane is there. I have the second choice is that like this way. 1, 2, 3, 4, 5, 6. So when I consider the longest chain as a straightforward, when I consider this longest chain, I have the 2 substituent group, that is the alkyl. Okay. When I consider the longest chain is like this way. So when I consider the longest chain is like this way. Okay. So in this longest chain, I also have the 2 substituent. So I have the 2 choice. That is this or this. Both choices are equal. Okay. So you go by this or this. Now second thing is that lowest number of the carbonate. Give the numbering to the chain so that what are the branched alkyl group. These are the branched alkyl group. This branched alkyl group has a lowest possible number. The number which indicating the numbering of this branched alkyl group are called as locant number. So here what is the locant number? 2 and 3 are the locant number where the alkyl groups are to be attached. Okay. Here also the locant number is 2 and 3 when I consider this parent chain. Now as I give the numbering from this side, so it has a locant number 2 and 3. But suppose I consider I give the numbering to this branched chain from this side 1, 2, 3, 4, 5 and 6. What happened here? Now the alkyl group has a number 4 and 5. So local number is a 4 and 5. So in this case I have to write the numbering in a such a way that I get a lowest possible number. So this lowest possible number is a 2 and 3. This is not a lowest possible number. So numbering by this side is wrong. So I have to give the numbering to the carbon chain, which is the parent chain, in a such a way that the alkyl group which is attached we will got a least possible number. So that you have to write the numbering of this organic compound. So this is the second rule called as a lowest local number. We also called it as a lowest local number. Now third rule is that identify. Third rule is that identify and name the branched alkyl group. So what are the alkyl groups which are attached to the given organic compound? They can identify. If this alkyl group attached, what are the branched alkyl group which is attached? If they are the same type or if they are the different type. The alkyl group is the same type or if they are the different type. If they are the same type, the alkyl group is attached with the same type, then we can, if the same type alkyl group are the 2, then we call it as a di. If the same type alkyl group are the 3, we call it as a tri. If the same type of the alkyl groups are the 4, we will call it as a tetrad. So, like this way, di, tri, tetrad, this prefix we can use. If the alkyl group are the different, then they are arranged by alphabetic order. They are arranged by alphabetic order. They are arranged by alphabetic orders. Look at, for example, I have this compound. So select the longest chain. The longest chain will be selected is this, or suppose I can choose 1, 2, 3, 4, 5 and 6. Okay. Look at. So what is my choice? 1, 2, 3, 4. If I go straight forward, again it has 6. When I go straight forward, how many branching are there? 1, 2, 3. But if I go by this way, CS3, CH, CS3, CH2, CH3. I write this ethyl is like this way, CH2, CH3, 1, 2, carbon number 3, then CH, CH3.